Welcome students. Now we are going to start objective type question of electromagnetic wave. So let's begin with the first question. The first experimental evidence of the existence of electromagnetic wave was provided by Cbse, Hertz, Maxwell or Marconi. The correct answer for this question is Hertz. Next question we have. Time-varying electrical field is produced along with time-varying magnetic field by a charge moving with uniform velocity, a conductor carrying electrical current, an oscillating neutron, an oscillating charge. The correct answer for this question is an oscillating charge. Third question. The time-varying electric and magnetic field in space produces EM waves which is propagate with a velocity less than velocity of light. To not produce EM wave, produce EM wave which propagate with velocity greater than the velocity of light. Produce EM wave which propagate with the velocity of light. The correct answer for this question is produced EM wave which propagate with the velocity of light. Students, the time-varying electric and magnetic field in a space produces electromagnetic wave which propagate with the same velocity which is the velocity of light actually have. Next question we have. A displacement current was named as current because it is similar to conduction current. It produces a magnetic field. It is a time-varying electric field. It is a current due to uniformly moving charge. The correct answer for this question, it produces a magnetic field. Next question. A condenser has trick conducting lead of radius small r and circular plate of radius capital R. During charging the condenser, Bc is magnetic field produces on the conductor and Vd is the maximum magnetic field produced due to the displacement current where R is less than capital R. So for that scenario, Bc is greater than Vd, Bc is equals to Vd, Bc is less than Vd or Bc is greater than or equals to Vd. The correct answer for this question is the magnetic field of a conductor is greater than magnetic field of a displacement current. Next question have the Maxwell equations integration of a vector B dot vector dl is equals to mu naught I plus epsilon naught d phi by dt is a statement of Faraday's laws of induction, modified Ampere's law, Gauss law of electricity, Gauss law of magnetism. The correct answer for this question is modified Ampere's law. Next question have Maxwell's equation integration of vector B dot vector ds is equals to 0 is a statement of Faraday's law of induction, modified Ampere's law, Gauss law of electricity or a Gauss law of magnetism. The correct answer for this question is Gauss law of magnetism. Next question. Maxwell equations describe the fundamental laws of electricity only, magnetism only, mechanics only, or both A and B. That means 1 and 2. So electricity only and magnetism both. Next question here. Maxwell equations integration of vector E dot vector dl is equals to minus d phi m by dt is a statement of Ampere's law, Faraday's law of induction, Gauss law of electricity, Gauss law of magnetism. And the correct answer is Faraday's laws of induction. Next question. Which of the following waves have the maximum wavelength? X-rays, infrared rays, UV rays, radio waves. The correct answer for this question is radio waves. Next question is, an electromagnetic wave passing through vacuum is described by the equation E is equals to E naught sine kx minus omega t and B is equals to B naught sine kx minus omega t. Then E naught is equals to B naught, E naught omega is equals to B naught k, E naught B naught is equals to omega k, Ek is equals to B naught omega. So little bit I'll just explain it, like what is the omega. This is the angular frequency or we are taking as angular displacement, angular velocity also. Okay, and k is wave number. The value of k is 2 pi by lambda. So for this question, they need solution that C is equals to, we know, E naught by B naught. So C is equals to N lambda. And we can say, if I'll just multiply by this value, so omega by 2 pi into 2 pi by k, this gives omega by k. Hence, we can say that n is equals to omega by 2 pi and k is equals to 2 pi by lambda. So, correct answer for this question is option 4. Next question is, let vector E, B and vector C represent electric field, magnetic field and velocity of an electromagnetic wave respectively. Their direction at any instant of a point along the direction of a unit vector. Given below in order, which of the following cannot be true? Students, keep in mind, here the question is asked, which of the following cannot be true? K cap, I cap, J cap, K cap, J cap minus I cap, I, J and K, minus J, minus I and minus J, minus K and minus I. The correct answer for this question is, what we are doing, like applying cross product rule. According to this, as you can see over there, the sequence. So this is not actually possible. So like if somebody will be asked like how and why we are saying, because of the cross product rule, if I'm just supposing this is I, J and K. So this rotation we are taking as a clockwise direction. So I, J gives K. Okay, I, J and K. Okay, then after, if I'm just taking K and J, so K we are taking opposite to the J. That means the I comes in negative. For that direction, that means this is correct. And if I'm just taking K and I, so for that scenario, J will be comes in the nature, so this will be correct. But in the case of a minus J and minus K, minus J and minus K, this will be gives like the direction of I, which is in plus I cap. If this will be mentioned over there, that will be true. But here the cannot be true is the fourth one. Next question, the electric field vector E corresponding to the plane electromagnetic wave is given by vector E is equals to vector E naught sine omega t minus x by c, where symbols have their usual meaning, like ratio omega by c is known as angular frequency, propagation constant, intensity or impulse. The correct answer for this question is that omega by c, omega means what? 2 pi nu, and c means nu lambda. So this will be gives k, which is a propagation constant we are saying as a wave number. Next question, the velocity of electromagnetic wave is parallel to B cross E cross B, E and B. So the velocity of electromagnetic wave is equals to E cross B. Next question, in an electromagnetic wave, the average energy density is associated with electric field only, magnetic field only, equally with electric and magnetic field. Average energy density is 0 and the correct answer is equally with electric and magnetic fields. Next question we have, a lamp radiates power P naught uniformly in all directions. The amplitude of electric field strength E naught at a distance small r from it is E naught is equals to P naught by 2 pi epsilon naught C r square. E naught is equals to under root P naught by 2 pi epsilon naught C r square. E naught is equals to under root P naught by 4 pi epsilon naught C r square. And E naught is equals to under root P naught by 8 pi epsilon naught C r. The correct answer for this question is, we know that P is equals to like 1.4 pi r square. P is equals to I into A. So here A is equals to 4 pi r square. So intensity I is equals to half C epsilon naught E naught square. So I'll just put all these values together and get this value. Hope you understood, students. This is the value of A naught like 1.4. I'll just, by mistake, I'll just term this cleared. So this will be P is equals to I dot A. 17th question is, the dimensional formula of under root mu naught by epsilon naught is, where the dimensional formula of mu naught is mlt minus 2a minus 2 and epsilon naught m minus 1l minus 3t 4a. So this complete formula is m0 lt minus 1, ml to t minus 3a minus 2, ml to t minus 3a2 and m minus 1l to t3a2. The correct answer for this question is ml to t minus 3a minus 2. Let's solve also like how to become. So now I'm gonna to use like this units ml t minus 2. So as if I'll just solve this term, so this will be m in the minus 1. If this big goes in the uppercase, that will be plus L 4 T. This will becomes upside, so this becomes minus, so minus. So 4 to 6, this will become 6. And a minus 2 again, this will becomes minus 4. So root, if I just remove, this will be single m, this will be 2, this will be 3, this will be 2. And this is a match with this. Next question, we have the frequency of X-rays, gamma rays and ultraviolet rays are respectively A, B and C. Then A is greater than B and B is greater than C. A is less than B and B is greater than C. A is greater than B and B is less than C. And A is less than B and B is less than C. The correct answer for this question is A is less than B, B is greater than C. Next question. If C is the speed of electromagnetic wave in vacuum, its speed in medium of a dielectric constant K and relative permeability mu r is V is equals to 1 by under root mu r K, V is equals to C under root mu r K, V is equals to C mu r K, V is equals to 1 by mu r C. The correct answer for this question is V is equals to C by mu r K. Next question, we have the electromagnetic wave do not transport charge, energy, momentum, information. The correct answer is charge. Electromagnetic wave do not transport the charges. Next question, an electromagnetic radiation has an energy 114.4 electron volt. To which reason electromagnetic spectrum belongs to? Ultraviolet region, visible region, infrared region, gamma ray region. The correct answer for this question is ultraviolet region. How we can calculate this particular energy like region? So we know that students, E is equals to H nu. Okay, so energy is given in the electron volt. We just convert it into the joule. So this will be 14.4, 1.6 10 to the power minus 19 joule. The value of H we know 6.63 10 to the power minus 34. So from here we can calculate the value of frequency, and we just search that from which frequency this will be lie. So that will be lie in ultraviolet region. Now we are moving with some numerical task. Earlier we are just taking the concept part of the objective question. Now we are moving ahead with the numerical part. The area of each plate of a parallel plate condenser is 144 centimeter square. The electrical field in the gap between the plate charges at the rate of 10 to the power 12 volt per meter per second. The displacement current is 4 by pi ampere, 0.4 divided by pi ampere, 40 by pi ampere, and 1 by 10th pi ampere. So let us see the solution part. A is given 144 centimeter square. So we have to convert it into meter square. This will become 144 10 to the power minus 4 meter square. So dE by dt is equals to 10 to the power 12 volt per meter per second. ID is equals to what? So ID is equals to epsilon naught A by dt E by dt. So ID is equals to 8.85 10 to the power minus 12, 144 10 to the power minus 4 10 to the power 12. From here we can calculate the value of ID, which is 8.85 10 to the power minus 4 times 144. After solving, this will become 0.1274 ampere, and which is approximately similar this value 0.4 by pi ampere. According to this, the correct answer for this question is option 2. So next question we have, a parallel plate condenser consists of two circular plates, each of radius 2 cm, separated by a distance of 0.1 mm. A time varying potential difference of 5 10 to the power 13 volt per second is applied across the plates of a condenser. The displacement current is 5.50 ampere, 5.56 10 to the power 2 ampere, 5.56 10 to the power 3 ampere, 2.28 10 to the power 4 ampere. So the solution part is, we know the value of R is given, that 2 centimeters. So firstly we have to convert it into the meter, which is become 2 10 to the power minus 2. This will be not 12, this will be minus 2 meter. Now next, D is given 0.1 millimeter. So we just convert this value 10 to the power minus 4 meter. So we know that the value of dV by dt is given 5 10 to the power 13 volt per second. ID we have to calculate. So ID formula we know epsilon naught A by d dE by dt. After solution, we get the value 5.56 10 to the power 3 ampere. Now how we will solve this particular term? So like for area, we know this will be parallel plate condenser. So for that, area of a sheet, circular plate. So this will be pi r square. This will be gives the area. T is already mentioned. Epsilon naught 8.85 10 to the power minus 12, and dE by dt. Time varying potential difference gives the value of actually voltage. So this will becomes 5 10 to the power 13 volt per second. So the value, just put all these value here and get the answer. Next question we have, a parallel plate condenser of a capacity 10 microfarad is charged with a constant charging current of 0.16 ampere. The displacement current is 0.16 microampere, 0.16 ampere, 0.96 ampere, 9.6 ampere. So let us see the solution of this question. What things we have to given? C, capacity 10 to the power minus 6 farad, 10 to the power minus 6 farad. IC given 0.16 ampere. So we know that IC is equals to ID and ID is equals to 0.16 ampere. So the correct answer is 0.16. So students, this things you have to prepare, like IC is equals to ID. Otherwise you just forget all the formulas. If so, C is created a confusion over there. But we don't use the value of a C, we just put this value of IC is equals to ID over there. Next question we have, a parallel plate condenser has a conducting plate of a radius 12 centimeter separated by a distance of 5 millimeter. It is charged with a constant charging current of 0.16 ampere. The rate at which the potential difference between the plates changes is 1 10 to the power 9 volt per second, 2 10 to the power 10 volt per second, 3 10 to the power 12 volt per second, and the fourth 2 10 to the power 9 volt per second. Solution we have, R is given 22 10 to the power minus 2 meter. So this is an actually radius is a given 12, by mistake this will be, so this is a 12, and we know that if we just put this value, so pi, the value for pi is 22 by 7, and we just square this, so we got the value 144. D is a given 5 millimeter, means 5 10 to the power minus 3 meter, or approximately we can take 10 to the power minus 4 meter also. Next, I 0.16 ampere, so dV by dt we have to calculate. We know that ID is equals to epsilon naught A by d dE by dt, and dV by dt is equals to ID epsilon naught A. Just put all these values. And got this value 2 10 to the power 9 volt per second, which is the option 4. Student, there will be a little bit confusion may if you have, like we saw ID is equals to epsilon naught A by d dE by dt. And some students if are thinking that ma'am here is a given E but we are using dV. Why? So we know that this one also, like V by D is equals to E. So instead of like V, if I just want to calculate, so this will be E into D. Clear? Or we just place the value of E, V by D. So if I just put this value, like in the place of E, we just put this value dV. So what will become dV by dt? Okay, with that, a D over there. So for that, if I just want to calculate the value of dV by dt, this will becomes ID divided by epsilon naught times E. So moving ahead, an AC source having a frequency of 50 Hz and voltage supply of 300 is applied directly to condenser of a capacity 100 microfarad. The peak and RMS value of a displacement current are 9.42 ampere, 9.42 by root 2 ampere. Like this we have a given. Now the solution part, N is given 50 Hz, V is given 300 volt and C is given 100 10 to the power minus 6 farad. So 10 to the power minus 4 comes in the nature. And we have to calculate ID and IRMS. Student, we know that IRMS is equals to V omega C and V omega is equals to 2 pi F or 2 pi N into C. We just put all these value and get the value of IRMS 9.42 and ID is equals to root 2 times IRMS. So the value of ID is equals to 9.42 times root 2. That means option 3 is the right answer. Next question, we have a parallel plate capacitor of a plate separation 2 mm is connected in an electric circuit having source voltage 400 volt. If the plate area is 60 centimeters square, then the value of a displacement current for 10 to the power minus 6 second will be 1.062 ampere, 1.062 10 to the power minus 2 ampere, 1.062 10 to the power minus 3 ampere and 1.062 10 to the power minus 4 ampere. Let's move with the solution part. D is given 2 10 to the power minus 3. Here the value of it is 2 millimeters. So when we convert it to the meter, 2 10 to the power minus 3. B 400. Next area 60 10 to the power minus 4 because this value is given in the centimeter. Next T is given T 10 to the power minus 6 second. So ID we have to calculate and ID is equals to A epsilon naught by D, which is equals to dV by dt. Now we just put all these value and get the result of ID. According to that, ID is equals to 1.062 10 to the power minus 2 ampere, which is the option 2. Next question we have of the topic, magnetic field produced between the plates of a parallel plate condensers or a capacitors. Students, I just want to little bit not confused. The meaning of a condenser is actually capacitor. The capacity of a parallel plate condenser is 50 picofarad and a magnetic field of 4 10 to the power minus 7 Tesla is produced at a distance of 10 centimeter from the axis of a gap. Charging current is 0.1 ampere, 0.2 ampere, 0.3 ampere, 0.15 ampere. The correct answer is C is given, B is given, R is given. Now we just convert if the value is given in the sequential form, like a picofarad is given 10 to the power minus 12, centimeter 10 to the power minus 2 meter. So we just convert all these values and we have to calculate the value of ID, displacement current. So we know that B is equals to mu naught ID by 2 pi R. We just put this value and get the value of ID, which is 0.2 ampere. Next question. The diameter of the plate of a condenser is 10 centimeter and it is charging by an external source with a steady current of 0.1 ampere. The source with a steady current of 0.1 ampere, the maximum magnetic field induced in the gap is 4 micro Tesla, 8 micro Tesla, 40 micro Tesla, 0.4 micro Tesla. Now let us see the solution. R is equals to 50 centimeter and if we convert centimeter into meter, 5 10 to the power minus 2 meter K. I is equals to 0.1 ampere, so we have to convert this 10 to the power minus 1. B we calculate. So we know that B is equals to mu naught I by 2 pi r. We just put this value and get the value for magnetic field, which is 0.4 microtesla. According to this, the correct answer for this question is 4th. Moving with the next question. The diameter of the plate of condenser is 10 centimeter and it's charged by an external source with a steady current of 0.1 ampere. The source with a steady current of 0.1 ampere, the maximum magnetic field is, the gap is 4 micro Tesla. This question we did. So we just move with this question. Question number 9 we have. A condenser of a capacity 50 picofarad is connected to an AC supply of 220 volt. Frequency 50 Hz. The RMS value of magnetic field at the distance of 5 cm from the axis is 22 pi 10 to the power minus 14 Tesla, 22 pi 10 to the power minus 12 Tesla, 44 pi 10 to the power minus 13 Tesla, 11 by 5 pi 10 to the power minus 12 Tesla. Now move with the solution. That how the procedure will we have to do. C is equals to 50 10 to the power minus 12 picofarad. So pico is 10 to the power minus 12. V 220 and N is given 50 Hz. And R is given 5 centimeters. So just put all these value. ID is equals to V omega C. So V omega 2 pi F. Now after substituting all these value, we get the value of ID, which is the 44 pi 10 to the power minus 9 times 25. We just put all these value like ID, mu naught 2 10 to the power minus 7. And one thing which I just want to explain over there, student. The value of a mu naught by 2 pi is 2 10 to the power minus 7. But the value of a mu naught by 4 pi is equals to 10 to the power minus 7 only. Clear? So these two things keep in mind. And after solution, you get the value of B, which is 44 pi 10 to the power minus 13 Tesla. Next question, we have a condenser of a charge using a constant current. The ratio of a magnetic field at a distance of r by 2 and r from the axis is, r is the radius of a plate. 1:1, 2:1, 1:2, 1:4. Solution we have B is equals to mu naught I r by 2 pi r square. So B is proportional to R, D1 by D2. B2 is equals to R1 by R2. R1, R by 2, R2, R. So B1 by B2 is a 1:2. According to that, the correct option is 3. Next question we have the electric field in the gap of condenser charges has 10 to the power 12 volt per meter per second. If the radius of each plate of condenser is 3 cm, the magnetic field at the edge of plate in the gap is 1.67 microtesla, 0.167 microtesla, 0.5 microtesla, and 5 microtesla. So now let us see the solution so let us see the solution of this question. dE by dt is given 10 to the power 12 volt per meter per second. R is given 3 10 to the power minus 2 meter. B is equals to, we have to find. So we know the formula B is equals to mu naught by 2 pi ID by R. We just put all these value and get the value of ID, which is 250.101 10 to the power minus 4 ampere. Now B is equals to mu naught by 2 pi ID into R. We just put all these value and get the value of B, which is 0.166 10 to the power minus 6, which is option 2. Next, EM wave and refractive index based questions. The refractive index of a medium of dielectric constant 2 and relative permeability 1.28 is 2.56, 0.8, 1.6, 1.3. Solution we have mu is equals to C air by C medium. We just put value together and relative case we get. So that will be root mu r relative permeability, and with that multiplication epsilon naught r, which is the relative permittivity. Put all these values together and get the value for mu r, which is 1.28. And refractive index of a mu we have to calculate. So mu is equals to mu r epsilon r. That is a 1.6 answer. Next question we have, the relative permeability of a glass is 3 by 8 and the dielectric constant of a glass is 8. The refractive index of a glass is, which comes 1.5, 1.14, 1.7, 1.6. Solution: mu is equals to C air by C medium. Again we apply the same formula and get the value of a mu is equals to under root of a mu r epsilon r. Mu r is equals to given 3 by 8 and epsilon r is given 8. We just put this value and get the value of 1.732, which is the root 3 value. According to that, the correct option is 3. Next question we have, the refractive index of a transparent medium for a light wave is 1.5. Assuming the impedance of free space of the wave is 376 ohm, the impedance of the medium 1504 ohm, 38.8 ohm, 250 ohm, 752 ohm. Solution: mu is equals to impedance in free space Z0, impedance in a medium, they have a ratio, which comes 1.5. So Z not 376. We just put this value of a Z. Z is equals to Z naught by mu. So this value comes 250.66. Relatively, this value equals to 250 ohm. According to that, the correct option is 3. Now we just move with the question relation between B and E. So the question is, a plane electromagnetic wave of frequency 40 megahertz travels along x-axis at the same point at same instant. The electric field E has a maximum value of 750 Newton per Coulomb in a y direction. The magnitude and direction of magnetic field is 2.5 microtesla along x-axis, 2.5 microtesla along y-axis, 2.5 microtesla along z-axis, 5 microtesla along z-axis. The correct answer for this question is, solution part, E is equals to 750 and Newton per Coulomb is given in y-axis. So V is equals to E by C. We just put this value 250 10 to the power minus 8 Tesla and 2.5 10 to the power minus 6 Tesla. We can say this will be along z-axis. Momentum and force. The light with energy flux 36 Weber per meter square is incident on a circular part of a radius 1.4 meter of a perfectly black body. The force experienced by a body and momentum delivered in 10 minutes are 2.2 micronewton, 7.2 micro kilogram meter per second, 3.5 Newton meter, micronewton, 7.4 micro kg meter per second, 0.74 micronewton for 444 micro kg meter per second, 7.4 micronewton, 2.2 micro kg meter per second. Solution: we know flux 36 Weber per meter square, radius 1.4 meter, area pi r is square, which is 22 by 7, and with that r 1.4, 1.4. So after solution, this will becomes area 6.16 meter square. Time 10 minutes, that means 600 seconds. Now P is equals to U by C. U, flux into area into time by C. So we just put all these values and get the result, which is a 444 micro kg per meter per second. Force P by T. So 444 10 to the power minus 6 by 600. This will become 74 10 to the power minus 8, which comes 0.74 10 to the power minus 6 Newton. Hence F is equals to 0.74 micronewton, which is option 3. Light with energy flux of 24 Weber per meter square is incident on a well polished disc of radius 3.5 centimeter for 1 hour. The momentum transferred to the disc is 1.1 micro kg per meter second, 2.2 micro kg meter per second, 3.3 micro kg meter per second, and 4.4 kg micro kg meter per second. Solution, we have flux is equals to 24 Weber per meter square. R is equals to 3.5 10 to the power minus 2. 6 is equals to 36. 100 second, 1 hour. So P is equals to 2U by C. For a momentum transferred, we have to ask that will be multiplied by 2. So after solving, the value of a P is a get 2.2155 micro kg meter per second, or approximately P is equals to 2.2 micro kg meter per second, which is option 2. Energy density. The maximum electric field of a plane electromagnetic wave is 88 volt per meter. The average energy density in joule per meter cube is 3.4 10 to the power minus 8, 13.7 10 to the power minus 8, 6.8 10 to the power minus 8, 1.7 10 to the power minus 8. So, solution, we have E is equals to 88 volt per meter. E average is equals to half epsilon naught E square. We just put up the value of epsilon naught, which is 8.85 10 to the power minus 12. And the value of 88 is the value of E. So we just put all these values and get the value of E average is 34,267.2 10 to the power minus 12. After solving a bit, we got this value 3.4 10 to the power minus 8 joule per meter cube, which is equals to approximately 3.4 10 to the power minus 8 joule per meter cube. Option first one is the correct. Next question which we have, in an electromagnetic wave, in vacuum, the electrical and magnetic field are 40 pi volt per meter and 0.4 10 to the power minus 7 Tesla. The magnitude of Poynting vector 4.4 watt per meter, 0.44 watt per meter, 5.65 watt per meter, and 4 watt per meter. Solution, we have E is equals to 40 pi volt per meter, V is equals to 0.4 10 to the power minus 7 Tesla. Poynting vector formula is S is equals to vector E cross vector B by mu naught. So after putting this value, we got this value 4 watt per meter. Intensity based questions. The intensity of electromagnetic wave at a distance of 1 kilometer from the source of power 12.56 kilowatt is 10 to the power minus 3 watt per meter square, 4 10 to the power minus 3 watt per meter square, 12.56 10 to the power minus 3 watt per meter square, and 1.56 10 to the power minus 3 watt per meter square. So let us move with the solution part. Power is equals to 12.56 10 to the power 3 watt. R is given 1 10 to the power 3 meter. I is equals to power by area. So power is given. Area 4 by R. So R is given. Just put this value. Get this final answer, which is 10 to the power minus 3 watt per meter square. According to this, the correct option for this question is 1. Next question we have, the intensity of a solar radius at the Earth's surface is a 1 kilowatt per meter square. The power entering the pupil of an eye of a diameter 0.5 centimeter is 39.2 milliwatt, 19.6 milliwatt, 9.8 milliwatt, 4.9 milliwatt. Solution I is equals to 1 kilowatt per meter square, which is 10 to the power 3 watt per meter square. To R is equals to 0.5 10 to the power minus 2 meter. R is equals to 0.25 10 to the power minus 2 meter. And P is equals to, we have to calculate. So P is equals to I into A, which is the area, pi R square. We just put all these values and get the result 19.6 10 to the power minus 3 watt. 10 to the power minus 3 represents the milli. This value represents the milli value because 1 milli is equals to 10 to the power minus 3. So, this is a milli. Milli is a prefix. Okay. So, this will be 19.6 milliwatt. According to this, the correct answer for this question is option 2. Next question we have a threshold of detection. An FM receiver can pick up a signal for which E0 is equals to 2 mu volt per meter. The intensity of electromagnetic wave 5.31 10 to the power minus 15 watt, 5.31 10 to the power minus 12 watt, 5.31 10 to the power minus 4 watt, 1.77 10 to the power minus 23 watt. Solution E0 is equals to given 2 mu volt per meter to 10 to the power minus 6 watt per meter. I is given epsilon naught C square RMS, epsilon naught C E0 by 2 root 2 square, 8.85 10 to the power minus 12, 3 10 to the power 8, and this value comes finally 5.31 10 to the power minus 15 watt per meter square. According to this, the correct option is a 1. Next question we have, the sun radiates electromagnetic energy at the rate of 3.9 10 to the power 26 watt. Its radius is 6.96 10 to the power 8 meter. The intensity of sunlight at the solar surface will be in watt per meter square 1.4 10 to the power 4, 2.8 10 to the power 5, 64 10 to the power 6, 5.6 10 to the power 7. So the value of P is given already 3.9 10 to the power 26 watt. R is given 6.96 10 to the power 8 meter, and I we have to calculate. So I is equals to power per unit area, which is a P by 4 pi R squared. We just put all these values and get the value of I, which is 64 10 to the power 6 watt per meter square, which is the option 3. So students, this is all for today's class. I hope you understand. I hope you learn many things. So bear with this group, which is a Nagin group of digital learning and a school. This provide you the core of the knowledge and the concept. So thank you for watching this video.